Hey everyone, today we're going to pull back the curtain on a discipline that's kind of like a secret weapon for building pretty much anything complex, from a mission to Mars to the smartphone in your pocket. It's called systems engineering, and it is all about tackling mind-bendingly complex problems. Let's get into it. But first, let's start with a question you've probably asked yourself. Why do so many big, exciting, ambitious projects just fail? The new subway line that's a decade late and billions over budget? Or that blockbuster tech gadget that lands with a total thud? It happens all the time. Why?
Well, it turns out the answer usually isn't a lack of smart people. Projects aren't failing because the engineers weren't brilliant or the vision wasn't bold. The real problem? It's a breakdown in the process. It's a failure to put a leash on the chaos. The genius is there, for sure, but the structure, that's what's missing.
So, before we can really appreciate the solution, we have to get a handle on the problem itself. Let's take a look at the exact conditions that make these big projects so difficult to get right. Think about what it takes to design a new public transit system for a city. You've got literally thousands of interconnected parts: trains, signals, power grids, stations. You have huge value judgments, right? Like which neighborhoods get a stop and which ones don't. You've got engineers, planners, politicians, and community groups who all speak different languages. And all of this is based on data that's probably flawed, trying to predict a future that's totally uncertain. It is a recipe for disaster. When you're staring down that level of complexity, just hoping for the best or winging it is a guaranteed path to failure. What you need is something called a management technology. It sounds a little jargony, I know, but all it really means is a structured, scientific, and repeatable way to manage the entire effort. And that management technology? Well, that's systems engineering. But it's really more than just a set of rules. It's a whole new way of thinking, a mindset designed specifically for these massive challenges. So what is it really? At its heart, systems engineering is all about organizing a flood of information so that people can make better choices. It's not about knowing all the answers right from the start. It's about building a framework that helps you find those answers, making sure that whatever you build actually works, is reliable, and, most importantly, solves the real needs of the people it's for. And this whole thing operates on 3 levels. Think of it like a stack. At the very top, you have systems management. This is the big picture strategy. For our transit system, this is where you decide, are we going to build this whole thing in one massive 5-year push, or roll it out piece by piece over 20 years? In the middle, you have systems processes. This is your step-by-step problem-solving approach. And at the bottom, you have systems methods. These are the specific tools you use, like simulation software or cost analysis spreadsheets. You've got to nail all 3. Okay, so what does this actually look like when you're doing the work? Well, it's actually built around a surprisingly simple core idea. It all comes down to asking 3 critical questions over and over again. And this is key. It's not a straight line. It's not a checklist you do once and then you're done. It's a loop. It's a cycle. You ask these questions, you learn something new, and that new information sends you right back to the beginning to refine your understanding. This loop is the engine that cuts through the fog. Step 1 is formulation. And this might be the most important step of all. It's about forcing yourself to define what problem you're really trying to solve. For our transit system, the problem isn't build a subway. No, the real problem is, how do we move people from their homes to their jobs quickly, safely, and affordably? This is where you dig in and figure out all the needs, the constraints, the goals, before you even dream of a solution. Okay, once you've defined the real problem, then comes analysis. This is the what-if stage. What are our options? A subway? More buses? Bike lanes? A mix of everything? Here you build models and you forecast what would happen with each choice. What's the cost, the timeline, the environmental impact? You're essentially mapping out the future consequences of each potential path. And finally, there's interpretation. You've laid out all your options and you've analyzed their impacts. Now you have to choose. This is where you take everything you learned in the analysis phase and you compare it against the goals you set way back in formulation. You rank your alternatives and you pick the best one, not based on a gut feeling, but on hard evidence. Now, this all sounds incredibly neat and logical, doesn't it? Formulate, analyze, interpret. Easy. But there's a huge twist. This entire rational process has to account for the single most unpredictable, irrational, and complicated component in any system you can imagine: So what do you think it is? What's that one wild card that can blow up even the most carefully laid plans?
Yep, it's us. It's human beings. Our brains are amazing, but they are not perfect, rational computers. And any system that's going to succeed in the real world has to be designed to work with, not against, our very human quirks.
So, the ideal is that we sit down, look at all the facts, and make a perfectly logical choice. But the cognitive reality is very different. Our minds just don't have the bandwidth to process all that complexity. So, to cope, we take mental shortcuts. They're called heuristics. And these shortcuts, while often helpful, can also be seriously flawed. And these lead to biases. For instance, there's anchoring, where a team gets fixated on the first budget number they hear, even if it's completely wrong. Or the availability bias, where planners might overinvest in preventing a rare but dramatic disaster they just saw on the news, while ignoring a much more common threat. My favorite is selective perception. That's where we unconsciously hunt for information that proves we were right all along. And of course, hindsight bias, the classic I knew it all along effect that stops us from actually learning from our mistakes. But here's the thing. Recognizing that our brains have these little glitches isn't a weakness, it's a massive strength. So how does building a process that expects human error actually lead to better results? Well, the payoff is huge. Because you're using a structured process, you make sure you really understand what people need. You end up with way more creative ideas because you're not just stuck on the first one that popped into your head. The whole team gets a much deeper understanding of the issue, and you can rank your choices with confidence, knowing they're backed by evidence. The end result? A product that actually works and that people can trust.
And this quote just nails it. The point of systems engineering isn't to take humans out of the loop. It's not about letting a computer make all the decisions. It's about augmenting us. It's about giving our brains a framework, a scaffold, to help us overcome our natural limits so we can apply our creativity and expertise where it matters most.
So at the end of the day, that's what it's all about. The goal is to get our thinking process out of our own heads, make it explicit, give it structure, so that we and our teammates can easily spot the flaws, challenge the biases, and build something together that's way more robust than any one of us could have ever created alone. And that leaves us with a final thought to chew on. Think about a complex system in your own life. Maybe it's a big project at work, a goal you have for your family, or even a personal health plan. How could you apply a little bit of this thinking, a little formulation, analysis, and interpretation to see it in a whole new light? Thanks for digging into this with me today.